Hello everyone, welcome to Module 4, Lesson 3 of Mastering Ethereum. Today we are going to uncover the essential concept of gas in Ethereum and understand why it is crucial for the ecosystem. To start, let's understand what gas really is. Gas is like the fuel that powers the Ethereum network. Just as cars require gasoline to drive, Ethereum transactions and smart contracts require gas to execute operations on the network. This gas is measured in units, and every transaction or contract execution uses a certain amount of those units. The concept of gas is crucial for understanding the cost associated with interacting with the Ethereum network. By understanding gas, developers can optimize their smart contract to minimize the gas consumption and reduce the overall transaction cost for users. This helps ensure the efficient and cost-effective operation of decentralized applications built on Ethereum platform. The importance of gas cannot be overstated. It ensures the efficient use of computational resources, preventing the network from being clogged by resource-heavy operations. Think of gas as a toll fee on a highway. The fee ensures that only those who really need to use the road will pay for it, keeping traffic manageable for everyone. Gas acts as an incentive for miners to include your transaction in blocks by rewarding them with gas fees. This way, it helps maintain the integrity and stability of Ethereum blockchain, similar to how toll fees help maintain roads and reduce congestion. By requiring users to pay for the computational resources they consume, the gas system encourages developers to write efficient and optimized smart contracts. This in turn benefits the entire Ethereum ecosystem by ensuring the network remains scalable and accessible to all participants. In summary, gas is the core element that keeps Ethereum network running smoothly and securely. Next, let's move on to two important concepts, the gas limit and gas price. The gas limit is like a budget for your transaction. It's the maximum amount of gas you're willing to spend to complete the transaction. It functions similarly to the maximum amount of fuel you decide to put in your car for a long trip. If you underestimate and run out of fuel, you won't reach your destination and transaction fails. On the other hand, putting in too much fuel means wasting money on gas you won't use. The gas price, on the other hand, is the amount of ether you're willing to pay per unit of gas. Imagine going to a gas station where prices fluctuate. Sometimes you pay more during peak hours to get priority service, and other times you might wait to fill up when the prices are lower. A higher gas price attracts miners to prioritize your transactions, but it will increase the overall cost, much like how paying tolls during rush hours might get you where you're going faster but at a higher price. Balancing the gas limit and gas price allows you to manage the cost and efficiency of your transactions effectively. The gas limit represents the maximum amount of computational resources a transaction can consume. This limit should be high enough to cover all operations within the transaction, ensuring its successful execution. If the gas limit is set too low, the transaction will fail, and any gas used up to that point will be lost. Conversely, setting the gas limit excessively high can lead to inefficient gas usage and overpaying for the computational resources required. Developers must carefully calculate the gas needs of their smart contract operations to find the optimal gas limit balance. Let's dive into how different operations consume gas. Arithmetic operations like addition and multiplication are relatively inexpensive. Think of them as routine checkups your car undergoes, quick and low cost. Addition costs 3 gas and multiplication costs 5 gas. These operations are fundamental and straightforward, so they don't consume much gas. However, storage operations such as reading from storage or S-load and writing to storage or S-store are much more costly. Reading from storage is like retrieving items from your storage unit. It takes time and effort, costing 200 gas. Writing data to storage can be compared to moving new furniture into a completely filled storage unit, requiring rearrangements and significant effort. This cost a staggering 20,000 gas per write. To develop efficient smart contracts, it's crucial to optimize these storage operations and prioritize cheaper ones where possible. Gas cost also depends on the complexity of operations. More complex computation requires more gas, while less complex requires less gas. Adding two numbers is a fundamental operation in EVM and costs only 3 gas. This low cost reflects the minimal computational effort required to perform simple arithmetic like addition, making it an efficient operation for smart contract developers to utilize. Similarly, multiplying two numbers in the EVM costs 5 gas. slightly more than addition but a relatively inexpensive operation. By understanding the gas cost of different EVM operations, developers can optimize their smart contracts to minimize gas usage and provide a more cost efficient experience for users. Prioritizing the use of cheap operations like addition and multiplication is a key strategy for creating efficient and gas optimized decentralized applications on the Ethereum network. Reading from storage using S-load operation is significantly more expensive than simple arithmetic calculations. Each S-load costs 200 gas, making it crucial for developers to minimize unnecessary storage excesses in their smart contracts. Writing to storage using the S-store operation is even more costly, consuming a whopping 20,000 gas per write. The high gas cost reflects the computational effort required to update the Ethereum blockchain state, which is a resource-intensive process. Due to significant gas cost associated with storage operations, optimizing the use of storage is a critical strategy for developers looking to reduce the overall gas consumption of their Ethereum smart contracts. Careful planning and efficient storage management can lead to substantial gas savings. Given the high cost of storage operations, optimizing storage usage becomes essential. Here's an interesting feature. Ethereum supports gas refunds, incentivizing efficient use of storage, much like recycling bottles and getting a small refund. You can earn a partial gas refund when you delete a variable from storage. This encourages careful management of your smart contract storage, aiming to recycle or clear out space when no longer needed. Let's look into this through a smart contract snippet. In this contract, Pragma Solidity specifies the compiler version, which in this case is 0.8.0. The contract name is gas refund. There is a variable stored data that has UN256 data type. The program defines a function set and clear, which sets a value and then deletes it. Deleting the stored data provides a gas refund similar to getting a rebate or refund when returning empty bottles for recycling. This mechanism encourages efficient storage management, allowing developers to lower their overall gas costs. By leveraging the gas refund feature, you can create smart contracts that are more cost efficient and optimize gas usage. The Ethereum virtual machine closely monitors and meters the gas consumption for every operation executed within a smart contract. This metering process is crucial for maintaining the integrity and security of the Ethereum network. As transactions are processed, the EVM keeps a running count of gas used, ensuring that the computational resources consumed align with the gas limit specified by the transaction sender. If the transaction were to unexpectedly consume more gas than the allotted limit, the EVM would trigger a revert, undoing the transaction and reverting any state changes. This mechanism prevents malicious or unintended code from draining the network's resources, protecting the overall system stability and reliability. Let us now look into errors that occurs due to low gas limit. An out of gas error occurs when transaction exceeds the specified gas limit. This means the transaction has consumed more computational resources than the maximum amount allowed, as defined by the gas limit. When this happens, the transaction is reverted and any changes made to the Ethereum blockchain state are undone. However, it's important to note that gas used in this transaction is not refunded to the user. The gas limit is set by the transaction sender to prevent the transactions from consuming an unlimited amount of computational resources on the network. If a transaction requires more gas than specified limit, the EVM will stop executing the transaction, revert any state changes, and return the out of gas error. This safeguard ensures the stability and security of Ethereum ecosystem by preventing malicious or poorly written code from overwhelming the network's resources. Before sending a transaction on the Ethereum network, it's crucial to estimate the amount of gas required for the operation. This can be done using tools like ETH_estimate gas, which provides a gas estimate based on the transaction parameters and the current state of Ethereum blockchain. Accurately estimating the gas requirement helps ensure the transaction will complete successfully without overpaying for the gas. By setting an appropriate gas limit, users can avoid the out of gas error, which occurs when transaction consumes more gas than specified limit, causing the entire operation to be reverted. Web3.eth.estimate gas function is being used to estimate the gas needed for a transaction before actually sending it on the Ethereum network. This function helps you determine an approximation of the gas cost required to execute a particular transaction. The estimate gas function call has two, which is the Ethereum address of the recipient to whom you are planning to send the transaction, and data, which is the data which will be sent along with the transaction. In Ethereum transactions, the data field typically contains an input data for smart contract functions to be called or specifies a contract deployment if it is a contract creation transaction. The data field is represented in a hexadecimal format. The estimate gas function returns the estimated gas cost as the result, which is stored in the estimated gas variable. The console.log statement is then used to print out the estimated gas cost to the console using string interpolation. The final output will be displayed with the message estimated gas, where estimate gas will be the actual value returned by the estimated gas function. This helps complete transaction without overpaying. Understanding gas price volatility is crucial for navigating the Ethereum network and optimizing transaction costs. Gas prices on the Ethereum network can fluctuate significantly based on the current demand for network resources. During periods of high activity, such as when network experiences a surge in transactions, the gas prices tend to increase. This volatility is driven by basic principles of supply and demand. To put it in perspective, think of gas prices as similar to the pricing of goods during busy shopping season. When demand for certain products is high, such as during a holiday sale or special events, prices tend to increase due to the limited availability of those goods. Conversely, during quieter periods, the prices may decrease as supply meets or exceeds demand. To help users navigate the gas price fluctuations, tools like Etherscan's Gas Tracker provides a real-time data on current gas prices. By monitoring these price trends, Ethereum developers and users can make more informed decisions about the appropriate gas price to use for their transactions, ensuring that transactions are processed efficiently without overpaying. Adjusting the gas price is a crucial aspect of optimizing transactions on the Ethereum network. Gas prices are not fixed and can vary based on network congestion and demand. When network experiences high activity levels, such as during a ICO launch or popular decentralized application release, gas prices tend to increase due to competition for transaction processing priority. To understand this concept better, think of gas price as a bidding process. Users are essentially competing with each other by setting their gas prices higher to incentivize miners to prioritize their transactions. It's like participating in an auction where bidders raise their offers to secure priority. However, unlike a traditional auction where the highest bidder wins, in the Ethereum network the transaction with the highest gas price gets processed quicker. Let us conclude with a summary of today's lecture. Understanding gas cost is essential for developing efficient and cost-effective smart contracts on the Ethereum blockchain. By optimizing gas usage and setting appropriate gas limits and prices, you can minimize expenses and ensure your transactions are processed smoothly. This allows you to build more robust and reliable decentralized applications that provide maximum value to your users. In the next video, we will explore advanced gas optimization strategies that can further enhance the efficiency of your Ethereum-based projects. These techniques will help you navigate the complexities of the Ethereum virtual machine and create truly optimized smart contracts. Before we wrap up, let's consider a few key questions to optimize gas cost in your smart contracts. How can you leverage strategies like gas efficient code, data storage optimization, and transaction batching to reduce the overall gas usage of your Ethereum based applications? What other techniques can you implement to ensure your smart contracts are operating at peak efficiency, providing the best possible experience for your users? We encourage you to share your thoughts and questions, insights in the discussion forum on Discord. The Ethereum community is always eager to collaborate and learn from one another as we collectively work towards building a more scalable and cost-efficient decentralized ecosystem. Thank you for watching, and we look forward to continuing our journey in the world of Ethereum.